10.2 continued. Question number 4 is saying, prove that the tangent drawn at the end of the diameters of a circle are parallel. Okay, so if this is your circle here, then there is any diameter you have to consider, then the tangents that will be drawn at the end points of this diameter, these two tangents come out to be parallel is what the question is asking you to prove. Okay, so in all these you'll have to explain the figure. Of course, you have to make the figure. Without figure, no marks. Make the figure, explain the figure, and then start with the proof. Okay, so you would say consider a circle with center O and let PQ and RS be the two tangents which are drawn at the ends of the diameter AB respectively. Then you have to prove that PQ is parallel to RS. So for the proof, consider any of these angles. I have taken these two. You can take on either side of it also. You can use alternate angle property. Okay, so to prove, now we'll say angle OP, OAP. This will be 90. This is the radius and this is the tangent. So we've done the theorem. Radius is always perpendicular to the tangent. Likewise, the other side, angle OBR I have taken. This would also be the same reason, radius perpendicular to the tangent. So this angle will also be 90. Okay, as I said, you could have taken maybe OBS. अगर आप ये वाला एंगल ले लेते तो फिर आप ये कहते कि ये alternate angles हैं जो 90 each equal आ गए हैं. And when alternate angles are equal, lines are parallel. I have taken on the same side, so I am quoting co-interior. So what I have done next is I have added these two equations. Okay, so angle OAP is plus angle OBR will be 90 plus 90, 180. So these are co-interior angles, we can see clearly, and they have come out to be supplementary. So for parallel lines, co-interior angles are supplementary. So we would say hence, since we've got the co-interior angles supplementary, the lines are parallel. Okay, so as I said, आप alternate angle की भी property quote कर सकते थे. Right, but in that case you'll have to take one angle that side, one angle this side. Okay, anyhow it can be done. Now the next question here is saying that prove that the perpendicular at the point of contact of tangent to a circle passes through the center. Okay, so point of contact से जो perpendicular बनाओगे. So suppose this is a circle and there is this tangent that we have considered. Here is the point of contact. Then if I do a perpendicular out here, this perpendicular will pass through the center. This is what we have to show. Okay, so what have we done here is we would say let AB be the tangent to the given circle with the point of contact P. Then we have drawn a perpendicular here. Let P and B perpendicular to this tangent. Okay, अब ये perpendicular आपने बनाया है तो ये angle 90 का होगा. That is what perpendicular means. So angle APN will be of 90 degree. One equation. Then now if I take angle APO this side, then that would also be 90 because ये अपने radius दिख रहा है and ये tangent हो गई. So because of the theorem. So this angle is 90 drawn and this angle because of theorem is 90. Okay. Now if I add these two angles together again, then 90 plus 90, this plus this is coming out to be 180. So this proved as a straight line. Okay, so adding these two angles, we are getting that NPO would be a straight line, or we would say NPO are lying on the same line. Okay, तो NP हमने perpendicular बनाया था and O हमारा center था. ये जो perpendicular है ये center से pass हो गया. This is what we had to show. Hence the proof. Okay, so we would say that perpendicular PN is passing through the center. That is what you had to prove. Okay, छोटे proofs हैं, but what is important here is you should get the diagram right. If you get the diagram right, your proof is very clear. And you should explain the diagrams because diagrams given नहीं है, ये सब आपके statements हैं. तो इसमें जब आप figure खुद बनाते हो, you've got to explain the diagrams as well. Okay. Now, sixth one, children, I've left for you all. You will try it on your own. I've done a number of times earlier this type of question. Okay, where they are saying about length of tangent from external point A is at a distance 5 from the center. पहले करें इस type के questions, right? ये A है, which is at a distance of 5 centimeter from the center maybe. And then this tangent's length of the tangents is given to you as 4 and they're asking you to find the radius of the circle. Okay, तो इस टाइप का कुछ figure बन जाएगा. This I'm just using that figure. Okay, and then you'll prove that this is 90, radius perpendicular to the tangent, so Pythagoras theorem is applicable. हमने कर लिए हैं, earlier we've done 2 questions of this kind, so try that on your own. I'll move on to the 7th one, saying that 2 concentric circles of radii 5 centimeter, 3 centimeter. You have to find the length of the chord of the larger circle, which will become or which touches the smaller circle. So somewhat this kind of figure comes for that. Okay, this is your larger circle, this is your inner circle, both of them having concentric means having same center. Okay, so this O is the common center for both. तो ये कह रहा है बाहर वाले का जो chord है such that it is touching the inner one, tangent to the inner circle, chord for the outer circle. इसका आपको length निकालना था. Okay, so somewhat like this the figure comes out to be. So what are we going to give the argument as? Consider 2 concentric circles with the same center O. That's the definition of concentric circles, and chord AB of the bigger circle touching the smaller circle at P. ऐसा कुछ बनाया है हमने. Then we have to find this length. For that, what are we saying? Angle OPA. Triangle OAP is a right triangle. Okay, because we know this is the tangent. O से इसे join करा आपने point of contact को, तो ये perpendicular radius हो गया. Okay, so here we can apply again Pythagoras theorem. उसने outer circle, तो ये OA will be radius of the outer circle, which is given to us as 5. OP will be inner radius, which is given as 3. तो again same type का figure आ गया. So we can again apply Pythagoras theorem and find this length of the tangent for the smaller circle, you can say, whichever way. So AP comes out to be 4 centimeters using Pythagoras theorem. Now this whole length, आपको chord निकालनी थी AB, which is double of AP. Why? Because class 9th, remember, we have done this theorem saying that perpendicular from the center bisects the chord. Okay, तो ये जो आपका radius है inner वाले का, वो इसके लिए chord के लिए perpendicular है. So it must be bisecting this chord. So AP हमने निकाल दिया है, तो double of AP will give you the value of AB. So AB is coming out to be 8 centimeters because of this theorem. Next question is saying that there is a quadrilateral ABCD shown here. ABCD figure is given to you. Then to circumscribe a circle such that the sides of the quadrilateral are touching the circle. Okay, then you have to prove that AB plus CD is equal to AD plus BC. A very simple proof. Okay, so for this figure here we would say, okay, like this, AB is equal to AS, AP is equal to AS, likewise BP is equal to BQ. ये सब external points हो गए. देखो A, B, C, D are external points and these are tangents to the circle, 2 tangents each from the external point, and they should be equal in length. So we'll use this theorem that tangents from external point to a circle are equal in length. Hence, likewise, from all these we can write 4 equations. CR is equal to CQ, DR is equal to DS. तो ये सारे equations लिख लिए आपने, same reason all of them. And now add these equations. Okay, AP plus BP. Okay, so from the figure also you can check, children. AP plus BP, AP PB is giving you this whole length AB. तो बस वही करना है आपने. AP and BP together give you AB. CR plus DR together gives you CD. तो आपका लेफ्ट हैंड साइड में आ जाएगा AB plus CD. These two together. Likewise, इस तरह की साइड आपको थोड़ा rearrange करना पड़ेगा. With AS you would consider SD. See in the figure, AS and SD. DS लिखो, SD लिखो, comes to the same. So AS plus DS is giving you whole of AD. Likewise, putting BQ with CQ. BQ, CQ. BQ, CQ gives you whole of BC. So hence your proof.